Okay, welcome everybody. Some Math 101. We're going to cover chapter 6.2 here. This has to do with sets and counting. This is from the textbook, is 6.2, sets, counting. So far you guys learned a lot about what constitutes a set and how we might write a set. Like we might say A is the set that contains the elements 1, 2, 3, 4, and 5, something like that. And we could say B is a set that contains the letters A, B, and C. These are both in roster form at this point. Now, when we get into chapter 6.2 and we start counting things, they introduce this little symbol, which is an N, but it has a little hook on it so you can know that this N means number of. And I might write something like, looks like this. And this would be read N of A, or you could also say number of elements in set A. In this case, it's the number of unique elements, so make sure you only count the people once. Nobody gets double counted. So for these two examples here, the number of elements in set A would be equal to 5, and the number of elements in set B would be equal to 3. When we look at some of the Venn diagrams they use in chapter 6.2, they'll introduce, of course, the set in terms of universal set up here. Then they might include set A and set B here. Now sometimes they'll go along and write different amounts of elements are in here. So this is different from chapter 6.1. In chapter 6.2, if I were to write something like a 10 in here, a 3 in here, and a 7 in here, that'd be saying that there are 3 elements in the intersection of A and B, 10 elements in A that aren't in B at all, and 7 elements in B that aren't in A at all. We can also write some numbers out here. So say I had 5. This would mean there are 5 elements outside of sets A or B. So those are the elements in the universe that are not in either. If I were to write these out here, I could say the number of elements in set A, I would have to add them up. 10 plus 3 gives me a total of 13. And in this case, the number of elements in B would be equal to 10. The number of elements in A intersect B, which you remember from chapter 6.1, means what's the number of elements in between both of them. That is common to both of them, I should say. That would be 3 elements. And another thing I might write from this setup here is that the number of elements in A union B complement, that would mean everything that is not in A or B, here's A or B, everything that's not in there would be equal to 5 elements. Now sometimes the problems they'll give you won't be as neat and they won't show you exactly who's in and who's out. So here's an example of a survey problem we might say. Say somebody said there are 30 people who take cream with their coffee. There are 20 people who take sugar. And there are 10 people who take both. And the question is, how many take only cream? Well, you might be initially inclined to say 30 take only cream, but in these type of survey problems, they're sort of asking you, let me scoot this over a little bit for you, they're sort of asking you, well, these people all selected cream and these people selected sugar. The people who are in this group, these 10, they selected both cream and sugar. So these 10 got counted in this group and they got counted in this group. Now there's a couple of ways to think about this. One of them is just using some sort of logic and pictures, and we'll do that way first. And then after that, I'll introduce a formula that will help you solve a lot of these problems. So If I were to draw a Venn diagram, put the universe up here, this is all people, I guess, drinking coffee. Over here we have this set A, these are the people who take cream. And over here we have the people who take sugar. Now we know the people who take cream is 30. I'm going to put it up here. Some people put it in different places. People who take sugar is 20. One thing I know is that there are 10 who take both. So this 10 has to fit down here in this little intersection because those people signal they take both cream and sugar. Now if I know that 30 people total took cream and 10 of them were counted in the people who took cream and sugar, how many must be out here in this section? These two numbers have to add up to the total of 30 people up here. So this would have to be 30 minus 10, which is 20. Same thing over here for sugar if we wanted to know. We had 20 people who had sugar. These are the people who had sugar. These people got counted in that group, so we better take 20 minus 10, which is 10. So now if we go back to the question, how many only took cream? Well, if you look here, what Venn diagram corresponds to that is just these people over here. So that would be 20. So there's a formula that goes along with this that you can use, and it looks like this. Cardinality of A union B, the number of people in the union of two sets, is equal to the number of people in the first set plus the number of people in the second set minus the number of people in the intersection of the two sets. Basically what this does is says you could find the number of people that's in either A or B by first adding the people in A plus to the people in B, and then subtracting one time the people who were in the intersection. These people got counted both in here and in here, so we have to take off one of them so that it equals out to the correct number. So some of the examples you might have in your homework might say something like, let's say that we know that n of b equals, sorry, that one's in the homework. Let's say that we know n of a. We know n of a equals 4. We know n of b, sorry, this is an n. We know n of b equals 5, and we know n of a union b is equal to 9. And they ask us to find n of a intersect b. Make sure this is an n. So this is like a lot of the problems in your text or in your first homework, first problem set. This one it's easy to apply the formula for, but we might involve a little bit of arithmetic or algebra in there to actually solve the problem. So what I usually like to do, I'm going to rewrite the equation up here. This is the equation that we know will always be true. And then I'm going to plug in all the numbers that I do know and try to figure out what's missing. So I know that the cardinality of the union is 9, so I'm going to write 9 equals, now I ask what's n of a, that's 4, plus what's n of b is 5. This is an interesting one, minus cardinality of a intersect b. So you could just put that whole thing here, or you can call that x. Well, this one turned out to be pretty easy, because if I look at it, I say what's 9 is equal to 4 plus 5 minus how many? In this case, 9 turns out to be equal to 9 minus x. What does x have to be in order to make these two equal to each other? It has to be 0. 9 minus 0 is equal to 9. So we have x is equal to 0. Whenever you get that situation, when the intersection is, there's nothing in the intersection of two sets, those two sets are said to be disjoint. Disjoint, which means no two elements in this, no elements in common. None in common. Sorry about if it's blurry and messy. Trying the Sharpie. See if it works. Let's do one more problem just like that. So this time it's going to be n of a. This one has three parts.